Okay. Okay, can you see my screen now?
Yes.
Okay, perfect. Okay, so now I'm going to show you this new software for the risk assessment of cosmetics called SheraCosmolife. Yeah, we have developed this software specifically for cosmetic industry, and the main goal of this software is to help to facilitate and harmonize and improve the safety assessment process of cosmetic industry for cosmetic industries. This is a Java application that works on every operating system, so Windows, Linux, Mac. This is the first screen, the first mask of the software. Here, the end user, for example, the safety assessor, has to do 4 main input operation, very, very simple operation because it is a very user-friendly software. The first one is the selection of the directory. So you have to click here at the top right, select directory, choose, for example, desktop, click on save. This means that you will find your output file on the desktop of your computer. The second operation is the selection of the list of the ingredients. So you have to add the ingredients, clicking here, add the new ingredient, and here you can enter the ingredient of interest using the INCI name or the CAS number or the SMILES. So we can see an example just to see how to include a substance. For example, sodium benzoate is a typical preservative used in cosmetic product. Using INCI, you have to type the INCI name here. Then you have to click the magnifying icon on the right, look up by INCI, and the software says found one match. Why? Because the software recognizes sodium benzoate within a database implemented within this software. Indeed, we have implemented this very articulated database with thousands of chemicals, and in particular with all the information retrieved from the European cosmetic regulation. And then I can show you in detail this aspect. Okay, I click OK. The software recognizes sodium benzoate within the database and provides also the CAS number and the SMILES. The software provides the original SMILES and also the neutral SMILES, because this software works only with these these neutral SMILES. The software cannot assess the substances using a disconnected SMILES. So, for example, the salts are neutralized, and other substances, for instance, mixtures or inorganics or polymers with a disconnected SMILES cannot be assessed by this software. Then the end user has to enter the concentration of this ingredient, for example, 0.5, and then click here, add ingredient, and the ingredient is now in the list of the ingredients. Then you can add other ingredients. You can create your list of ingredients, your formulation, for example, your cosmetic formulation. Then you can save, clicking here, save to file. You can save this list, this formulation within an existing folder, or you can create your new folder. And then if you want to change or modify something, you can upload again this list of ingredients, clicking here, load from file. Okay, you have to search the folder with your data, with your list of ingredients. I can show you an example. Okay, open, and the list of ingredients or your formulation, depends on what you have created, appears now in this list of ingredients. And then you can modify, you can play with the software, and for example, you can add another ingredients. For example, if you decide to use, I don't know, another preservative, you can add, for example, phenoxyethanol. Okay. Put the concentration. Okay, phenoxyethanol is now together with the other ingredients, or you can modify the concentration of the ingredients. For example, for glycerin, you have to click here and then this button, modify ingredient, and you can change the concentration. For example, not 3, but 6. Modify, and now the concentration is 6. Okay, so basically you can play with the software, and you can create, save, and upload your formulation. Then the last operation is to select the product type. Here on this drop-down menu, there's a long list of different product type, such as shower gel, shampoo, body lotion, face cream, and so on. Maybe you can select the body lotion. When you select the product type, the software provides creates automatically an exposure scenario, because we have implemented within the software a list of different exposure parameters, such as the frequency of application, the time of exposure, the retention factor. So the software can recognize if a product type is a leave-on or a rinse-off product, and so on. So the software provides and creates this exposure scenario. And then the input operation are finished. You have create your list with the concentration, you have selected the product type, and then you can start the evaluation, clicking here, run a calculation. And the software in a few seconds, 15, 20 seconds, I think, with this list, will provide the output report with the assessment of all the ingredients. Okay. Okay, 17 seconds. Okay, this is the first output, is a sort of preliminary summary output table with summary of information for hazard, for example, here for mutagenicity and skin sensitization, the percentage of absorption, the calculation of the margin of safety, the assessment done with the threshold of toxicological concern. And then if you click here, on the left on details, the software provides a detailed report for each ingredient. So I try quickly to explain you something about this table. For example, the software provides an assessment using an experimental value. If this experimental value is present, otherwise the software provides a prediction using one of the in silico models, the QSAR models implemented within the software. The software uses different colors for the assessment. Basically, for a good assessment, when we have a non-mutagen, non-genotoxic, non-sensitizer compound, the software uses this green. In particular, this green when we have an experimental value or a good reliability prediction. Otherwise, for a moderate or a low reliability prediction, the software uses a sort of faded green. On the contrary, for a bad assessment, for a sensitizer or mutagen compound, the software uses this red. Also in this case, red for experimental value and good reliability prediction, or this orange for moderate or low reliability prediction. But we have to refine better also this graphical aspect related to the colors. And the reliability is the same, explained by Emilio for VEGA, is the same concept, the same use of the applicability domain, and the same approach for the reliability. I continue, clicking here on details, for example, for potassium sorbate, the software provides this detailed report. At the first part, there's a sort of summary with information that you have selected before: the cast, INCI, product type, the concentration. The software provides also a picture of the structure of this ingredient. There's a summary of the exposure parameters that I mentioned before for the creation of the exposure scenario. We use the parameters provided by the SCCS Note of Guidance, the 10th edition. As you know, I think the last week has been released the new version, the 11th edition of this SCCS Note of Guidance. So for sure we will use this for the updates, for the refinement of the software. Then start the real detailed report. Is divided in 7 sections. Section 1 is related to the regulatory information. As I said before, we have implemented this database with all the information retrieved from the European cosmetic regulation. So the software is able to recognize if an ingredient is present or not within one of the annexes of the European cosmetic regulation. For example, for potassium sorbate, the software recognizes this ingredient in Annex 5 in the list of preservatives allowed in cosmetic product. And the software provides also other information, for example, the maximum concentration for use preparation. Then we decide to include other regulatory information, for example, information retrieved from the CLP, the Classification, Labeling and Packaging Regulation. And we start to include also information retrieved from other countries, other regulation. For example, the software provides this information retrieved from the safer chemical ingredient list created by the US EPA. And then the goal for this section is to include also other regulatory information from other regulation. For example, we are in touch with Chinese or Taiwan regulatory bodies, and we want to introduce also information from these new regulation from China, from Taiwan, Korea, and so on. So this is the main goal for this section in the future version. I proceed with section 2 and 3 related to exposure, section 2 for external exposure and section 3 for internal exposure. Very interesting is here for internal exposure, we have created a new workflow starting from the calculation of the KP, the skin permeability coefficient value, using two existing equation based on two very simple molecular descriptor, molecular weight and partition coefficient, octanol water partition coefficient. And then multiplying Kp by water solubility, we get this value, Jmax, the maximum flux of a chemical across the skin. And then we apply the Croes approach. According to Croes approach and based on Jmax value, we can obtain 3 different levels of absorption. A low level of absorption corresponding to 10%, medium level of absorption corresponding to 40%, and high level of absorption corresponding to 80%. So based on this Jmax value, the software provides these 3 different levels of absorption, and we can use one of these threshold, this value, for example, in this case, 40%, this medium level, for the calculation of the systemic exposure dose, an important value for the cosmetic safety assessment. Okay, so section 4 is a section for related to hazard identification. Now we have 3 toxicological endpoints: mutagenicity, genotoxicity, and skin sensitization, with different QSAR models for this endpoint. And for this section, we want for sure to refine this section with new, and we will refine this section with new models, new toxicological endpoint, such as skin irritation, for example, or high irritation, two very important endpoints for the safety assessment of cosmetics. But we have models also for acute toxicity, models for endocrine disruptors. So in the next version, we will create a complete toxicological profile in this section. Then section 5, Noel, is it is a dose response assessment section. Now is focused on the pod, the point of departure, and in this version we use Noel as a point of departure, and the software uses an experimental value if it is present, or a prediction using the QSAR model implemented within the software. Also for this section, we have done a lot of work. We have new models for Noel and also for Loel. We are working, and recently we have developed also models for Noel and Loel related to organ-specific toxicity, so for liver, for kidney, for example. So we will refine for sure also this section with a lot of new information. So now we use Noel for the risk characterization, for the calculation of the margin of safety. Margin of safety is the ratio between Noel, in this case, or point of departure, and the systemic exposure dose. And it has to be higher than 100 to consider safe an ingredient. Then the last section 7 for TTC, a threshold of toxicological concern. Here the software uses Kramer decision tree implemented in VEGA, and it is the same algorithm implemented in TOX3. With this decision tree, the software provides a classification into one of the 3 Kramer classes, 1, 2, or 3, with the respective threshold value. And then the software provides a comparison between this TTC threshold and the exposure value previously calculated in section 2 and 3. And according to the definition of the TTC, if the exposure is higher than the TTC threshold, so in this case we can consider that the ingredient doesn't pass the exam, the test of the TTC. Otherwise, if the exposure is lower than the TTC threshold, as definition, there will be no appreciable risk for human health, is the definition of the TTC. Okay, so okay, finish. This is a very quickly practical demonstration.